In this video, I'm going to show you how to use our alternative to Yenka, the logic gate simulator online, for creating logic gates and logic circuits with multiple gates in them. I'll do my best to keep this right. This is slightly less familiar to me than Yenka, but I've used it a couple of times, and I'll do my best to make sure I give you all the correct instructions. So the first thing you'll see on this page is that it's a free website, so it's maintained by this person, Dominic Ford, and all of our tools are down the bottom. So they're a bit easier to find than in Yenka. We'll start off by demonstrating how an AND gate works. So we select AND gate from our tools at the bottom, and we'll click on our screen to place it. We've got to be careful with this. When we want to move things around, we can't just click on them. We have to select the move icon at the bottom here, and that allows us to move things on the screen. You'll see that there are options for positive and zero inputs, and that can be useful if we want to put ones and zeros into a gate. But what you'll find as you work with different models here, that it's actually better to take two positive inputs and put a switch in between them and the gate. Now, and I'll move these around and tidy them up a second. So we've got an AND gate here, we've got a switch, and we've got these one inputs. Why am I doing this? Because if I wanted to change my inputs to 1, 0, 0, 1, 0, 0, I'd have to continually delete those positive inputs and put in zero inputs. Here, what I can do, I can use this wire tool to connect these up. I can make these ones or zeros simply by putting the switch on or off. So currently, I'm going to connect these up to this AND gate here. These are both zeros that are going in because I've actually not closed the switch to make it a 1 to flow through. So this is how we can have switching between the 0 and 1. So that's how you want to set up your inputs to a gate. We want to have a way of knowing what the output is. And so we can use this component here, the LED output. This will go on. I think it's red when it goes on if it's got a positive signal, and it'll be stay blank when it's got no signal or 0 coming to it. Now, you notice if I close both the switches here, nothing actually happens. And that's because in this particular web page, you have to press the play button first to run our simulation. And now I've pressed the play button, you can see what happens straight away is the two 1 inputs up until the switch are colored red. And that tells us within our logic simulator, this is at value 1. You notice if I close the top switch, the red line now continues all the way up to the AND gate. And that's telling us that the top input to the AND gate is set to 1. But we know with AND gates that we need both inputs to be 1 for there to be a positive output. So if I close the second gate, we've got two 1s going in. And if you look at what happens on the right-hand side, the wire there goes red. And of course, our LED indicator lights up. So if you're using the logic gate simulator instead of Yenka, your first task is going to be to take the 3 main gates we're using, and or not, and set up the inputs, the 1s going into the switch, and test that you can make these outputs appear the way we'd expect them to. When I'm finished simulating, I want to press the stop button here to stop our simulation, and that allows me to go back to building our circuit. So you can see on the bottom, we've got our NOT and an OR gates. Just now, I'm going to delete everything that I've got so we can build something else. So I'm going to select the delete icon down here, and I want to click on the various things on the screen so we can tidy it up and build something else. On page 14 of the Digital Electronics course notes, there's an example of a burglar alarm system which uses a NOT gate, an OR gate, and an AND gate in order to simulate having a master switch, a light sensor, and a pressure pad, which give us the conditions for when an alarm bell should go off. So I'm going to build this up just now and show you how we can make a system like this. So it has an AND gate at the end. It's got an OR gate that goes into the AND gate. It's also got a NOT gate, it's one of the inputs for the AND gate as well. We're going to have 3 inputs for the system, so I'll put 3 on here just now. And of course, I need 3 switches so I can toggle between on and off. I'm going to move these around in a second. And the last thing I'm going to need is an LED output to show what the system is saying. So I'll put that here. Now I'll start to tidy this up using the move button. I can connect my AND gate straight into the LED. I'm quite happy with that. In the OR gate, I'll use a wire. Just click on the output and drag to join it to my AND gate. And I'll go back to the move icon, bring my NOT gate up here. I have a wire going in this side because that's what happens in the model. And I'll have my 3 inputs. So I'll go back to the move icon and move them back here. We usually have our 3 inputs lined up. I'll move this up a little bit. So what happens in the model is it says the master switch needs to be on. So that's going to be one of the conditions we have going into the AND gate. This top switch is going to represent the master switch. And I've just slightly missed that there, so I'm going to go back to move. I'll delete that wire, I can't quite join it up. So go into new wire tool, and from the circle there, I'll join this up. So this is our master switch here. And then it says the master switch is on, then one of 2 conditions is met. And either the pressure pad is pressed, so this second switch is going to represent our pressure pad, or the light beam is broken. So that means the light beam is not on. So it's going to be the opposite of the light beam working, which is why we've got this NOT gate here. So NOT gate connects to the switch, and the switch connects to the 1 input there. So I now have my 3 switches set up. And remember, the bottom switch represents the light beam being broken, which is one of our triggers. So when we press play, you can see we've got a red signal coming out from the NOT gate through the OR gate up to the AND gate, because that bottom switch is currently telling us the light beam is broken. But of course, under normal conditions, our light beam is not broken. So we've got no signal going into the OR gate from there. So these are the 3 choices we have. Now the system has a master switch, that's our top one. So no matter what I press for these 2, even when both of them are switched on going into the OR gate, so 2 red lines going into that OR gate there, the AND gate is not going to give a positive signal. The alarm bell, which is our signal at the end, won't switch on. However, if I switch the master switch on and then toggle either of these, you can see the indicator light goes red there. If I open it again, it goes off. If we break the light beam at the bottom, the indicator light goes off there as well. So we can see that we've modeled the system correctly. And indeed, if you go to page 14 of the course notes, you'll see this is, well, roughly what it's in the right order of gates, but a little bit messier than that. So we'll stop this just now. The other thing we're going to make a use of quite a lot when we build up some of the different systems in our assessment is labeling. We want to be able to give names to different parts of our circuit so that it's a bit more meaningful. So I'll put this up here and click on, if I click text and click on it, it's going to ask me to enter a label. So I'm going to type in master switch and press OK. So let's put a label up here, and I can put that next to the top switch. So now I know what this represents. I'll put in another label that says pressure pad. And press OK, and again I can move that about to be the pressure pad. I'll put in 2 more labels, one that says light sensor, and finally a label that says alarm bell at the right hand side. And now we have a circuit that makes a bit more sense, because not only do we have some switches and gates, but if we run our simulation, we can see if the master switch is on or off. We now notice the master switch because we've labeled it. And the master switch is off. The light beam is broken at the bottom, so our alarm bell on the right-hand side is going off. So when we build up systems that are going to represent something, that's what you'll do in the assessment. We're going to use labels to make sure we know which input is which, and that the system has some kind of meaning. So we'll stop the simulation there. But the last thing we have to do is make sure that we save our file as well, because you need to submit this to me in order to do the assessment. There's a couple of different options here. So the save button here will download this JSON file here. I'll also export SVG, which will export simulation file. And if I want to go and load a file, load and go into my downloads just now. It's going to let me open up either of these, I think. I know it doesn't like that. So the version you should be using is the JSON file. So that's when you click the save button. So don't click export SVG, click save. What I certainly will do, because this isn't as necessarily stable as the Inca, is that I'll be running through and doing checks on all of this before I set the assessment for this. So be assured that if you are using this instead of Yenka, we'll double check, make sure everything is working the right way before you're asked to submit your assessment. So the next thing you'll be doing is going through the 3 logic gates, not, and, or, and making sure you can get the right outputs. And then looking at the logic circuits we looked at in exercises 2 and 6, it's the same form both, setting up those circuits and checking that we can get the same outputs as well. Make sure we can get this app working in the way we need it to, so we'll be able to use it successfully for the assessment.